Hello Amithyans, my name is Manoj Kumar and I am uploading my sixth video and we will continue same exercise 7.2. See the statement of question number 7. Find the coordinate of A, where AB is the diameter of the circle whose center is 2 minus 3 and the coordinate of the B is 1 and 4. Here we have to find the coordinates of A. See the solution of this question. You can see its diagram. In a circle, AB is the diameter whose center is O. The coordinates of O is 2 minus 3 and the coordinate of B is 1 and 4. We have to find the coordinates of A and let us suppose the coordinates of A are xy. Here we will use the midpoint formula and we know that the midpoint formula x1 plus x2 divided by 2 and y1 plus by 2 divided by 2, and now put the values of a and b and the o, and after putting the value you will see we will get here x plus 1 upon 2 which is equals to 2 and another value y plus 4 divided by 2 which is equals to minus 3, and substitute the values of x and y, and after simplification you can see the value of x is 3 and the value of y equals to minus 10. See the 8th question. In this question a and b are minus 2 and the coordinates of b are 2 minus 4 respectively. Find the coordinates of the p such that AP equals to 3 by 7 AB and where P lies on the line segment AB. This question is very interesting. Why this question is important? In previous questions, the given ratio is given, but in this question, the given ratio is not given. So, in first step, we will find the ratio AP to PB, which is not given. Only this is given. AP is equals to 3 by 7 into AB. So in first step, you will find the value of here PV, which is equals to AB minus AP, and now you will use this value which is given AP, and that value is here 3 by 7 AB, and simplify this. Taking AB is common, and what is left inside the bracket 1 minus 3 by 7, and you will get here the value of PV is here 4 by 7. Now you will find the value of here AP upon PV, which is required ratio, and after putting the value of AP and PB you will get here the ratio is 3 by 4, which is the required ratio. So we can say here the point P divides AB into 3 ratio 4, and now after getting this value, this required ratio, you will find the value of the coordinates of point P, and you can find the coordinates of P by using section formula, and we know that what is the section formula, and put the values of A, B and the given ratio in the section formula, and you will get here 3 into 2 plus 4 minus 2 upon 3 plus 4 and 3 minus 4 plus 4 minus 2 upon 3 plus 4, and after putting the value you will see in the next step we will get here after simplification 6 minus 8 upon 7 and minus 12 minus 8 upon 7. So coordinates of point P are here minus 2 by 7 and 20 by 7. Now we will start new topic, the area of the triangle. In previous classes we know how to find the area of the triangle, and we will use this simple formula. Area of triangle is equals to half base multiply altitude. But in this topic When the vertices of triangles are given whose coordinates are A, B and C. Figure you can see the point A, B and C are given and the coordinates of A are x1 by 1, coordinates of B are x2 by 2 and the coordinate of C are x3 by 3. And we will use this formula and half x1 into by 2 minus by 3 plus x2 by 3 minus by 1 plus x3 by 1 minus by 2. With the help of this formula, we can find the area of a triangle. When A, B, C, the points of a triangles are given and whose coordinates are x1, y1, x2 by 2 and coordinate of C are x3, y3, and we will use this formula here to find the area of a triangle. And this is a special case. When your triangle, area of the triangle is equals to 0, we will say the vertices A, B and C are lies on a same line and we will say the point A, B and C are collinear point. Please note down, when area of triangle is equals to 0, we will say the point A, B, C are collinear points. Before start exercise 7.3, once again you will see which formulas we have to use in this exercise. First formula is area of the triangle. It is very important. If A, B and C the points of our triangles and whose coordinates are x1, y1, x2, y2 and x3 by 3, then area of triangle is equals to half x1 into by 2 minus by 3 plus x2 by 3 minus by 1 plus x3 y1 minus by 2. This is very important formula. And see the special case, if your area of triangle is equals to 0, we will say A, B, C are collinear points. You know when which points are said to be the collinear points? When these points are lies on a straight line. Now I am going to solve the very first question of exercise 7.1. Find the area of the triangle whose points are A, B and C. The coordinates of A are here 2, 3 and the coordinates of B are here -1, 0 and the coordinates of C are here 2, -4. Here you will assume x1 is equals to 2, by 1 is equals to 3, x2 equals to -1, by 2 equals to 0, x3 equals to 2 and by 3 equals to -4. And you will write down this formula, area of triangle is equals to half x1 by 2 minus by 3 plus x2 by 3 minus by 1 plus x3 by 1 minus by 2. And now you will put the values of x1, y1, x2 by 2, x3 by 3. After putting the value, you will get here 2 into 0 plus 4 plus minus 4 minus 3 plus 2 into 3 minus 0 and simplify them. After simplification you will get here 1 by 2, 8 plus 7 plus 6 which is equals to 21 upon 2 square unit. See second question. In second question you will find the value of the k for which points are collinear. Now this is given, these points are collinear. It means area of triangle is equals to 0. In second questions, the given points are collinear. So we know that what is the meaning of this? It means these points A, B and C lies on a straight line. And area of triangle is equals to 0. Here the coordinates of A are 7 minus 7 and -2. And coordinates of B are 5 and 1 and the coordinates of C are here 3 and k. You will compare the coordinates of A with the x1 and y2, and coordinates of B are x2 by 2 and the coordinates of x3 and by 3. Now points are given, so we can write here the area of the triangle is 0. Now you will use the formula of area of triangle and you will compare with the 0 and then put the values of x1 y1 x2 by 2 x3 and by 3. After putting the values, you can see we will get here 1 by 2 7 into 1 minus k plus 5 into k plus 2 plus 3 into minus 2 minus 1 equals to 0, and simplification its left hand side, and after simplification we will see here 1 by 2 into 7 minus 7k plus 5k plus 10 minus 9 equals to 0. Then 1 by 2 minus 2k plus 8 equals to 0. Do cross multiply because 1 by 2 is a common, and after this we will get here minus 2k plus 8 equals to 0, and find the value of k, which is equals to k equals to 4. See the third question. Find the area of the triangle formed by the joining the midpoint of the sides of the triangle whose vertices are 0, minus 1, 2, 1 and 0, 3. Find the ratios of this area to the area of a given triangle. In third question, ABC is a given triangle whose vertices are 0, minus 1, 2, 1 and 0, 3, and D is the midpoint of AB, E is the midpoint of BC, F is the midpoint of AC. In first step, we will find the midpoint of AB, BC and AC. And we know that what is the midpoint formula, and by using midpoint formula we will find the coordinates of D, and we will get here the coordinates of D are here 1 0. Once again I want to repeat, by using midpoint formula. And what is the midpoint formula? X1 plus x2 divided by 2 and y1 plus by 2. In same way you will find the coordinates of E and F, and the coordinates of E are here 1 2 and the coordinates of F are here 0 3. Now we will get here two triangles. First triangle is here A, B and C, and the second triangle is here D, E, F. According to question, we will find the ratios of D, E, F and A, B, C. One by one, we will find the area of both triangles. In first case, here we will find the values of area of triangle A, B, C. And we will compare the coordinates of A are x1, y1 and the coordinates of B are here x2 by 2 and the coordinates of C are here 0 and 3, and put these values x1, y1, x2, y2, x3 and y3 in area of triangle ABC, and after substituting the value you will see we will get here the area of the triangle is equals to half 0 1 minus 3 plus 2 3 plus 1 plus 0 minus 1 minus 1. And now solve this equation, and after solving you can see we will get here half into 0 plus 8 plus 0, and then we will get here the area of the triangle is here 4 square unit. Now we will find the area of a triangle DEF, and again you will see the coordinates of D are here 1 0 and coordinates of E are here 1 2 and the coordinates of F are here 0 1, and you will compare the coordinate of D are x1 y1 and the coordinate of E are x2 by 2 and the coordinates of F are x3 y3. Now you will put the values of the coordinates of D, E and F in the formula, and we know that what is the formula to find the area of the triangle. And after putting the value of x1 y1 x2 by 2 x3 y3, we will see 1 by 2 into 1, 2 minus 1 plus 1 into 1 minus 0 plus 0 into 0 minus 2, and simplify this equation, and after simplification we get here 1 by 2, 1 plus 1 minus 0, and which is equals to 1 square unit. Now we have the areas of the both the triangle ABC and other triangle DEF, and then according to question we will find the ratio of both areas of both triangles, which is equals to area of triangle DEF upon area of triangle ABC. And now the area of DEF is equals to 1 and the area of ABC equals to 4, and our required equation is here 1 by 4. Now last question of this exercise. In this question, a median of the triangle, divide it into two triangles of equal area and verify this result for triangle ABC whose vertices are A, B and C. Coordinates are 4 minus 6, 3 minus 2 and 5, 2 respectively. In this triangle A, B and C, the vertices of the triangle whose coordinates are A, whose coordinates are 4 and minus 6, B coordinates are 3 minus 2, and the C the coordinates are 5 and 2. And in question it is given AD is a median, AD is a median, and we know that a median divides opposite side into two equal parts, and we will prove it. D is the midpoint of BC, and by using midpoint formula we will find the coordinates of here D, and the coordinates of D are here 3 plus 5 divided by 2 minus 2 plus 2 divided by 2, which is equals to 4, 0. We know that median divide a triangle into two equal parts, and we will prove here in this question the area of the triangle ABD is equals to ADC, and one by one we will find the value of area of triangle ABD and the area of triangle ADC, and the areas of both triangles should be equal. In first step we will find the area of a triangle ABD, and the coordinates of A are, we will compare with the x1 y1, and the coordinates of B are here x2 by 2, and the coordinate of D are here x3 and by 3, and we will use here the formula of area of triangle, which is equals to half x1 by 2 minus by 3 plus x2 by 3 minus by 1 plus x3 by 1 minus by 2. And now put the values of x1 y1, x2 by 2 and x3 by 3. After putting the values we will see 1 by 2 4 minus 2 minus 0 plus 3 into 0 plus 6 plus 4 minus 6 plus 2, and after simplification we will get here the area of the triangle, which is equals to minus 3. Area of triangle we will get here minus 3, but we will not take the area in a negative, so we will write down here the area of triangle in positive, that is equals to 3 square units. Now in same way we can find here second part, the area of the triangle ADC, by using the formula of area of triangles, and which is also equals to 3 square units. So hence we will write down here a median of the triangle, divide it into two triangles of equal areas. With this question our 7th chapter is finished, and students, you will do the written practice of all the exercise questions again and again.